What does the future look like? Alex Salkever has been thinking and writing about this for 2 decades, covering AI and chat GPT, green energy, genetic engineering, cloud computing, self-driving cars, and more. A former Business Week editor, he is the author of 4 award-winning books examining the impact of technology on society and our well-being, including The Driver in the Driverless Car, How Our Technology Choices Will Create the Future, and Your Happiness Was Hacked. Alex has worked as a senior technology executive for multiple technology companies in Silicon Valley and contributes articles to leading publications, including Fortune, MarketWatch, CNBC, and Foreign Affairs. On behalf of Nallas, I am very happy to introduce Alex Salkever as he presents to you AI and the future of technology infrastructure. It's all going to change.
Thank you so much, Lori. Hi, everybody. Really glad to be here today. This is a topic that I find absolutely fascinating, partly because literally every day you learn something new. For example, today Google released a new connection to Bard so that Bard will tap into your Gmail, your calendar, all kinds of other things. Microsoft is continuously releasing interesting products. So really the world is going to change. And behind all of these software changes that we see on the surface are big infrastructure changes that are coming as well. And I'm going to present some slides to talk about this a little bit, and hopefully this will help explain some of what's going on. And also we will have some time for Q&A at the end if you have questions. So let's get started with the presentation. So first of all, I wanted to explain, or at least talk a little bit about the impacts that we're already seeing with AI for computer code and developers. This was not too long ago. This was actually in June, but the GitHub CEO, Thomas Dohmke, said he expects that Copilot will write 80% of code sooner rather than later. So that's pretty remarkable considering that right now Copilot does not write that much code, but it's writing more and more code, and it's really good. And a lot of people who use it love it. And not only is Thomas saying this, in articles, he is walking the talk as well. So here at Web Summit, not too long ago, I think this was also in June or around that time frame, he actually built a snake game live on stage, coded entirely from scratch in 18 minutes using Copilot. So any of you out there who are a developer or understand how developers work, you kind of get a grasp of how significant this is, because doing that live on stage without a net, this was not a canned demo. He actually did all the live coding. The live coding himself was pretty remarkable. And it gives you a little bit of a sense of how much faster we'll be able to code and how much faster we'll be able to do things. So this is a little bit about me. Lori already gave this quick introduction. I don't want to last on this too long, but those are the 3 of the books I've written. But let's keep moving. So what we're going to talk about today is exponential curves, and specifically as they relate to infrastructure. Human beings tend to think in straight lines or in slight slants. So when we see tomorrow, we think 1 + 2 + 3. We don't think 1, 2, 4, 16, 64. But that's what's actually going to be happening with technology, and it's already happening with AI. We are seeing progressions of AI capabilities that are following much more like exponential curves. And that's partly because we have so much data, and it's partly because the compute's better. But in general, we will be very surprised by what we're seeing happening tomorrow as compared to today. And what this exponential curve is unleashing in AI in general is a whole bunch of new opportunities. So each of these 4 businesses, none of them are possible without AI. All of them are using AI and large language models as a key element. And all of these businesses are relatively new. And when you look around, you're already seeing an explosion of new businesses, many of them doing really interesting things, which might have been possible before, but would have been either a lot more expensive or would have been a lot more labor intensive and compute intensive. At the same time, we're seeing an explosion of new risks alongside AI. So this is an article from the Wall Street Journal. It's pretty recent. It talks about how AI startups have a lot of cash, but not enough data. And that's because already we're starting to see many companies becoming a lot more cautious about the data that they're sharing with the AI systems, because they realize that the large language models that have grown to date have been built on top of publicly shared data. So one of the new risks is going to be for all of your data that's out there publicly, do you want it to be trained on AI? Are there things out there that you don't want the large LLMs to see? Another risk is, how are you going to buy the data you need to fuel your LLMs? So maybe some of it's an internal data, but if you need external data, that's going to be more expensive and fast. A third risk, which is implied here, is that we actually have a shortage of GPUs and AI-specific compute power. We'll talk about that a little later, but that's a real risk because we are seeing a developing world of GPU haves and have-nots. The large companies that can afford the big clusters that are required for the training runs, and the smaller companies that can't necessarily do so. And they can through cloud providers, but they still can't do the massive training runs. So here's our agenda for today for the talk. Rapid technological change in AI. I'll go over the steps that got us here, the impact of AI on infrastructure, some AI risks, both to infrastructure and more generally, and how to think about AI in your work and in the way that you approach your business. So AI is clearly altering the cloud business forever. You're seeing articles like this all over the place. All of the major cloud providers are building new data centers that have lots and lots of AI-specific compute integrated. Companies like Nvidia are also entering the market. They're now a cloud provider specialized on AI. You have new clouds forming like CoreWeave that are designed for AI. So what we saw in terms of the cloud business before, primarily being driven by legacy compute, by things that you might see as servers, that will continue. But AI is going to be bigger than all of that over time because it's just a more compute intensive business. And the data required for AI is also so massive that this is going to stretch the cloud and make it harder for us to get sufficient capacity in the near term, although over the long term, we'll all probably be okay. And when I say altering the cloud business forever, this, for example, is one of Microsoft's new AI-specific cloud data centers in Iowa. They collaborated with OpenAI to build data centers that are customized to handle what they believe will be the needs of AI computing. And you're seeing more and more of these data centers where AI is the first-class citizen, and it is really the reason why they've built the data center. And Microsoft is not alone. Google's doing this, CoreWeave is designing this, and Nvidia as well are doing all of these things. So I mentioned Nvidia. Their platform is called DGX, and it is a platform where you buy it not just because you get access to the best GPUs, but also because you get access to really smart people at NVIDIA who can help tune your models or help you do what you need to do with AI more easily and more efficiently. Now, that being said, most of the other providers like Microsoft, et cetera, are catching up, and they're going to be offering things that are just as good in cloud. And in many respects, what they offer right now is just as good. So you might need NVIDIA for more complex or really hard stuff, whereas most of the things that you're going to be able to get in Azure or other clouds like that will probably be useful for the average business. By AI also, I mean things like running an LLM model, a large language model on your data set, using it to do inferencing on your products, or more specifically, machine vision through the cloud, which is already on offer from AI, fraud detection, lots of things that we actually did in the past are made much better with AI. So let's talk a little bit about how we got here and rapid technology change. So if you look at this chart, you can see on one side is electricity. That took us about 40, 50 years to absorb and see mass penetration. Then you see the telephone, the radio, television, all of these getting shorter and shorter until we see the web, which took about 10 years to absorb and get mass penetration. So you can see over time clearly that adoption curves of technologies are shrinking. And that's the framing that you want to have here, because with AI, the adoption curve is potentially the fastest ever. So the top line there is OpenAI ChatGPT. It took about 3 months to get to 100 million monthly users. Compare that to Instagram, to Pinterest, to all the other products there, and you can see it is among the fastest adoption curves we've ever seen. Now, granted, this is not necessarily the same as a general purpose technology like electricity or television. This is just talking about Chat GPT, but it's a pretty good proxy for how interested people are in AI and how much of a mass market there is for the product. AI has been bumping along, growing steadily, really for the last 5, 6, 7 years. But in the last 2 years, it took off like a rocket. And in the last year, that's where we've really seen this remarkable improvements as the newest large language models like ChatGPT, like Bard, like Anthropic's Claude come to market, and people finally see, this is a tool that I can use to do things that I do in my normal life. So what got us to this point? Really 4 elements. One, of course, is very cheap computing. And that's something that we've seen all along, which is moved faster and faster. And as it follows Moore's law on a curve downwards, when you buy compute today, in general, it costs about half as much as it did 2 years ago to get the same amount of compute. And that's continuing. And we'll see even more of it as the EU continues to take hold and we see more types of new processors coming online. So TPUs, all kinds of other bespoke processors. Apple is building their own processors. Microsoft, Meta, all of them are designing processors specifically for their needs. So the second component is ubiquitous connectivity. So you probably remember not too long ago, you had a 3G connection, and that was pretty fast on your phone. And you had broadband, and maybe you could download movies pretty quickly, and they would be all right. Today, we are expecting everything to get delivered yesterday. We mostly have 5G connections. We have very fast broadband at home. Many of us have gigabyte speed broadband, and we're getting more options. So we see things like Starlink, which gives us connectivity not just in our homes, but even if we're driving around the country in an RV or we're traveling. And that really makes a big difference, because when you connect the compute with the connectivity, then the next stage, the sensors become more interesting and useful, because the sensors are connected back to the cloud and the compute, and they're useful for taking information from the world and turning it into labeled data, which can both fuel applications and give us insights, and also be used to train large language models. So that's a picture of an of an Apple Watch, which is basically a sensor platform. All of the things that you see it do, from sensing that you move your arm to reading your blood, your blood oxygen level, your pulse, your temperature, or sensing other things about the environment. That's part of what's now built into not just Apple Watches, but many, many, many other types of platforms, both for consumer and for industrial products. So as we've gotten more and more of these sensors, and they've really wired up the world, that has created enormous amounts of, you see on the opposite end of the slide there are the maps, enormous amounts of really good structured labeled data. So I picked a map because a map is a really good example of data that is well labeled, is well known, and is useful for machines, because machines can look at maps or look at the geographic data that powers maps and use it to understand, to analyze, to make decisions, to interact with. Maps are one type of data. We have lots and lots of other kinds of data, and they're all coming in. And because they're coming in through sensors, and also we're working harder and harder to label it and structure it, all of this data is becoming more and more useful over time. And when you add these 4 things together, then you get magical AI. So I say magical AI, I mean something like ChatGPT, or something like what you see with Bing, when you can ask it questions and it will write things for you. Things that really 2 years ago you would have never imagined an AI could do, or that do things which otherwise you would have spent 20, 30 minutes, an hour doing, writing an email, writing a press release, potentially brainstorming a list of article ideas for a publication or a marketing plan. All of these you can do with AI. And not just these types of things that all of us see, but also things like protein folding for scientists, creating entire video clips or 15-minute short films out of AI-generated video, deep fakes, which the criminals are using for spoofs and business email compromise campaigns. So all of this is something that I like to call magical AI. What made this work is, first of all, the GPUs, which I mentioned before. And GPUs originally were created to deal with video games and refreshing screen content, which is a parallel action. You're refreshing lots of things at the same time. And that happened to also be a perfect use case that mapped over to artificial intelligence, which processes in parallel and relies on being able to process many streams at the same time. That's how the deep neural networks, which are used to create foundational models and train LLMs, that's how they think. They think in lots of parallel processes. So as GPUs became ubiquitous and more powerful, AI became easier to run. At the same time, we got much better algorithms. And these algorithms continue to improve, and they allow us to process more and more data and to make our AI work more quickly and to train it on less compute. So even though we're training it on massive amounts of compute, we've been training it on less and less on a per capita basis. And that's really powerful and important, because without these better algorithms, we probably wouldn't have been able to so quickly roll out many of these improvements in AI. And the last bit, which we talked about in the last slide, is the data. And the data really is the key here, because without good data, AI is not useful. None of the things that we're seeing it do for us in daily lives would have been any good if the data that it trained on was really bad. And we can kind of get a sense of that as well when you see these examples in the not so distant past of, for example, chat engines that go off the rails and spew unpleasant stuff. That's because it's trained on data which teaches it to do that. And also, when you see things that are, for example, bad labeling of images that maybe that's incorrect, that's because the data it was fed was not very good. So now we've hit a critical mass when it comes to good data, and that makes a big difference. So how does all of this impact infrastructure? By infrastructure, I'm talking about all of the things that we see right now, which connect back and forth to us, to our factories, to our cars, up in the sky, and of course to the data centers and the server closets and all of the places where we have the servers. So it's really important to understand that compute is starting to move everywhere, and that it's not just going to be primarily in data centers. In fact, that's been true for quite a while. iPhones and smartphones are super powerful, and they act as very strong compute nodes in your pocket. There's lots of other compute platforms that don't look like compute platforms, such as Teslas, which are actually now running neural networks on the cars, that have come into being. And we also have compute platforms that are super distributed, like a lot of the satellites actually have servers on them, and they may be able to do some AI work lightweight in orbit when they're doing some of the stuff. So 4 components of how it will directly impact infrastructure. There's going to be an enormous increase in the compute required. That means GPUs and TPUs, other types of AI compute. We're going to need lower latency and more ubiquity for critical AI apps. By that, I mean, for example, if we're running a driverless car and we have to push an over-the-air update, it has to get there very quickly. Or if you have a phone and it is feeding medical data that is important for, say, you have some kind of device to protect your heart, or some other type of medical device, you want that data to be pushed back up into the cloud and into the AI systems that are helping make that decision loop much faster. And when I say ubiquity, that's the other side of latency. Latency means back and forth quickly. Ubiquity means getting closer and closer to where you actually need to make the decision. By doing that, AI will be more powerful and more useful. Better networks, of course. That means things that run faster. And you're already seeing this inside of the AI data centers, where we're seeing 2 or 3 new types of protocols coming out that are specifically designed to help AI clusters or clusters of AI compute move data back and forth across their networks more quickly and easily. And of course, we need to store more huge volumes of data and recall it in more useful ways. And that's what's driving the vector databases and the new types of databases that are really designed to handle AI. And lastly, we are going to see smaller AI apps running everywhere on everything. So yes, right now we're largely seeing a big AI running out in the cloud, and we ask it a question, it goes to a data center and comes back. In the future, we'll have lots of little AI apps that are smart and doing things on the devices all around us. So a couple of examples of this, please. This is a chart of satellite launches over the last 30 years, basically. And you can see that giant line going up and to the right. These are Starlink and many other satellite providers that are papering the skies with these low Earth orbit satellites and really creating the equivalent of a giant network in the sky, which will be used for AI because it will reduce our latencies and will also do interesting things around sensing, like give us much better image coverage of the Earth. We're already seeing bits and pieces of how this works. But another example is AI platforms on wheels. I talked about this a little bit. So most of the driverless cars that you're seeing around the cities, the Waymos, the Cruise in San Francisco, they have LiDAR units, they have radar sensors, they have cameras, they have other types of sensing platforms all running on them, which are collecting enormous amounts of data. So many of these cars will generate terabytes of data every day. And that data is really granular data about the world around us, which is super useful and will be used to fuel AI. But it also means we have to have easier ways to push that much data, store that much data, work with that much data, and then over time, send that data back down to the cars. Maybe not quite as much, but to make sure that that data gets there very quickly. I mentioned the idea that iPhones and other devices like that are essentially already AI compute platforms. So when we look at the phones right now, they're a lot more powerful than PCs were a couple decades ago, and they're more powerful than the original supercomputers. And they're getting more and more powerful. So Apple's new chips, the A17, has a GPU attached to it, which is very, very good for AI, should Apple choose to light that up. All of us are going to have GPU supercomputers in our pockets, or the equivalent of that compared to what GPUs used to be able to do. And that really changes the game with regard to infrastructure, because it means that we move away from cloud computing, even beyond edge computing, to something that some people call fog computing, where the compute is ubiquitous, the AI is ubiquitous, all of this is around us all the time, and it's a matter of where we want to run the processes and what we do with the data there. Apple will probably really put a strong emphasis on this because they historically have liked to keep people's data private on their devices, okay? And they've also always liked to have the smartphones be fairly self-contained. Other providers may do different things. So I'm sure, for example, Microsoft will have really interesting AI capabilities on its tablets, which do very well. And they may mirror some of these, or they may choose to have more of a connected capability. There are enormous ripple effects from these infrastructure changes. So this was information that was culled from the latest Microsoft report. There was a 34% spike in Microsoft water consumption as a result largely of AI and data centers. There's similar issues with carbon. So AI generates an enormous amount of CO2 because of all the compute that's required. So not saying that this is necessarily a problem. It would be if we chose not to address it, but this is actually driving really interesting innovation in data centers and the way we handle and manage data centers, because now things like water that used to be something we cared a lot about, we care a whole lot about, because Microsoft will have to do a better job, or will have to reduce water consumption if it's going to still be a good citizen in some of these communities. And that's true across all the cloud providers, not just Microsoft. It's also true across Google, Amazon, everybody else. So a really good way to think about AI is it is a general purpose technology that makes predictions very, very cheap. So what do I mean when I say that? By the way, this book is a phenomenal book. I highly recommend it. It's one of the best books that is a basic explainer on the economics of how AI will change business and society. It's not about technology per se. It's much more economics. But what it talks about is what happens when things that used to be very expensive, cognitive tasks or cognitive capabilities, become really, really cheap because they become on the same cost curves that we see technology right now. So for example, machine vision, being able to recognize objects. That used to be something that you needed people for, or you needed people watching streams, or you needed people watching the machine vision systems because the machine vision systems were not accurate enough. All of a sudden, as AI gets better and better at it, we no longer have to worry about that as much, and you can just let the AI handle a lot of it. Same deals, for example, if you're doing business analytics. AI will get better and better and better at understanding analytics, at interacting with people who ask it basic questions or questions in normal languages. And that makes it possible for all of us to get access to cheap predictions. So the reason why we say predictions is because the core capability of large language models is not necessarily true cognition like we're used to thinking about our brains, but prediction. So what these models do is they look at all the data they've been trained on, and when you ask it a question, they predict what they think the answer to that question should be. It's not based in the physics of the world or truths or anything like that. It's more about how can I predict what I think should come after A? Should it be B or C? And that's why you see some interesting edge challenges to AI, where, for example, it can make predictions, but it's a little fuzzy, so the predictions seem a little weird. And I'll give you one example of that further out. But a good way to think about this is what in the infrastructure realm that requires making predictions, so configuring networks, setting up new servers, optimizing compute, what of these kinds of things could predictions becoming cheap really influence? And I think there's a whole lot of them. So part of the economics of AI as well is that it's just getting better and better and better. And that's really essential because as we look at what it is doing on a cognitive breakdown, if it weren't doing it better than people, then it really wouldn't be something we'd be interested in. Because as humans, we look at AI and we say, it makes a mistake, therefore it must all be bad, even if it's at 95% of what humans are. So as we get more and more used to AI that's better than we are, we will start to change the way we view it and view it much more comfortably as an extension, like glasses on your face, a calculator, or things that can make us superhuman. Now, what that will do out in the world is it will really change our expectations of how we interact with lots of devices and what we're capable of doing in the physical world. In the infrastructure world, this will probably also require that we continue to build out more and more ubiquitous capabilities around AI, because it's no longer going to be okay for your smartphone to have a snafu if it's something you're also using as not just a hearing aid, but a translator. So with AI, there's a much more intensive compute lifecycle. You have the training models, which are enormous and very expensive, and that's the stack here. And then later on, you have running applications, which is less intense, but still requires a good amount of compute. To give you an idea of the training models, the latest ChatGPT training run probably cost OpenAI around $50 million. So the very, very large training model, the very, very large LLMs cost an enormous amount of money to train. That being said, not everyone will have to create a giant LLM like OpenAI to get something useful. So I talked about the training runs and the compute lifecycle. This is just the chart showing you the amount of teraflops required to run and train these large AI systems. And you look at the trend, it's obviously up and to the right. What it doesn't show as well here is the size of the data sets that it's being used to train on. So this sounds a little remarkable, but as it's been training, it continues to actually become more and more efficient, but it still has to consume more and more compute for it to do its job. And so we mentioned data. So this shows the number of data points that are being used to train notable artificial intelligence systems, and you might call these tokens if you're actually in AI. And that's the smallest unit that is used to train systems. We break down text, visual, images, everything into vectors and tokens. You can see that curve, and when you look at the very top level, training on 1 trillion, in the not so distant future, probably within a year, we will eclipse 1 trillion, I think we already have, and probably head towards something closer to 10 trillion. Part of that is because the more data that we use to train large AI, the better the AI tends to be. And you remember I mentioned how big the training data sets are. If you look at the bubbles, you'd see that The bubbles on the far right, which is the more recent, larger training sets, they're absolutely massive. They just dwarf the smaller training sets. We're going to see that trend continue, and we're going to see those bubbles get bigger and bigger and bigger. Now, right now, big tech companies are the dominant providers of AI. Google, Microsoft, Stanford's not really a company, but they're closely aligned with a lot of these other big tech providers. As you look at all of these folks too, it makes you understand that right now it's a big tech company's game, and they have a lot of advantages in being able to deliver large language models or give you access to the kind of compute that's required. So at least for the near future, probably the cloud providers will have a significant advantage over the smaller companies. That being said, we are seeing quite a bit of interesting open source in this space. And so Llama 2 is a large language model that Meta released a couple of months ago, which really broke the mold because it gave everybody who was interested in large language models a clear explanation of how they built it. They open sourced the model weights. So with large language models, model weights are essentially the tuning settings that you use to make sure that the large language model works well and gives outputs that are appropriate for what you're trying to do. Just releasing a model, the code of the model is not all that useful. People still have to spend a lot of time training it. Releasing with the weights means it's much closer to something that you can white label or more easily interact with. Meta actually released it with a license that let people build businesses on it with some restrictions. And it was trained on a whole lot of data. Not surprisingly, several of the major cloud providers are letting you use Llama 2 on an as-service basis. And you're seeing more and more organizations start to create their own LLMs based on their data. For example, marketing agencies are now starting to create their own generative AI systems based on Llama data. This is the front page of Hugging Face. Hugging Face is the equivalent of GitHub, except for open source AI models. And there are now hundreds of thousands of open source AI models. Not all of them are great or useful, but it gives you a sense that open source is really gaining ground. And there's a very vibrant range of tools in the open source community that are being delivered and really customized. And that's the beauty of open source too, right? You can do that for lots of different use cases. And as you build out these different pieces of open source, you will start to see specific vertical capabilities or specific AIs. And so on the one hand, we are seeing these giant LLMs, like we talked about, Bard, GPT-4. On the other hand, we're now starting to see much smaller LLMs that are more focused on vertical use cases. I'll talk about those in a minute. So even small organizations can run smaller versions of Llama or other AIs. So this is just a chart showing you how much RAM and VRAM and the types of graphics cards might be required. Obviously, as you get up to llamas with 65 billion, you're going to need more. And keep in mind that this is running inferencing. This is not necessarily running the same full training models that Meta did, but it gives you a sense that, yes, you can have your own AI running in your own cluster or on your own cloud or your own cloud formation if you want to run something smaller and you have a pretty specific idea on what you're trying to do. And part of that is because I mentioned the algorithms are becoming more efficient. You can see from this chart, each one of them shows how much compute is required to get to a roughly 80% proficiency level on recognizing an image. So as they move steadily downwards, that means there's less and less compute required to achieve a base level of competency. And I expect that to continue going, though maybe not quite as quickly as this. But essentially, it's going to be collapsing the cost of running AI for inferencing for applications in the near future. So another thing that's really important to understand with regard to infrastructure is context and context length. Okay, so the context length is how many tokens can an AI interact with or inference in a single session. That's important because if you have a short context window of maybe a few thousand, that means you can't give it too much data for your session and expect it to be able to answer questions authoritatively without you having to go back and forth and refresh. So Anthropic, their AI system, Claude, which is publicly available, has a very large context window, almost as large as a book. And so you can upload PDFs or large documents into it and ask questions and analyze it. And this unleashes some pretty interesting use cases. And I think that you're going to see more and more differentiation on context length over time. Different AIs will be good for different things, or you'll be able to toggle your context length a lot more aggressively. So I mentioned lots of different LLMs that are coming to the market or coming out. This is just 3 of them. The top one there with the beautiful map images, that's actually an LLM that was released by NASA and IBM of global geospatial data. Bloomberg introduced their own GPD, which is trained all on financial data. Meta released a separate LLM that's focused on text to audio or manipulating audio. And the key thing here is these data sets, these LLMs, they were trained on specific and very good data sets, much smaller than the training that was required for the large LLMs. So with LLMs that are vertical specific, you can train on small but very good data sizes and actually get great results. So the data quality matters. So we're going to see a lot of diversity in AI, and that's going to mean that on the one hand, we have lots of compute required driven by the large LLMs. On the other hand, you'll have probably things like these, which will run in smaller footprints, and be quite accessible to a lot of mid-size businesses. So a little bit of some of the risks and some of the realities around this, and this isn't necessarily specific to infrastructure. Chances are your employees are using AI at some level. There was an interesting experiment that the government of Italy created without realizing it was doing it. It banned ChatGPT, and this was for a couple months. And some smart researchers said, okay, let's look at GitHub pushes in Italy across a bunch of developers, see what happens, and also see what other things are associated. So they saw in the first week a 50% decline in GitHub pushes, releases, and they saw a massive spike in search for VPN tools and Tor installs. And then the GitHub releases actually went right back up a week later. So in Italy, the developers went around the ban because they found that the tools are so useful that they wanted to do it themselves. Generative AI is rapidly going mainstream. So right now in one survey, we're seeing 71% of organizations, of digital agencies, are already using it. So you should definitely expect that your competitors are going to be using it. If you're not using it already, just think about the infrastructure you're going to need to use it. It also brings many, many security risks. So we see instances of ChatGPT being used to spread malicious packages and software. Samsung actually banned it because employees posted sensitive IP without understanding that it was going to be included in cloud training sets. And you have hackers that are using deepfake voices for business email compromise. So how to think about AI in general? A really smart research team out of MIT, Boston Consulting Group, and UPenn created what they call a jagged frontier of AI capabilities. And what that means is that we don't necessarily understand exactly what AI is good at yet. We have some ideas, but we're going to be trying lots of things. And in lots of areas, AI will be better than what we think it will be at. In other areas, it'll be worse. And so they call that the jagged frontier. And I highly recommend you Google this topic and look for the research that just came out on it. It's some of the most interesting research around this area to date. Now, I wanted to end talking about some of the really amazing opportunities that come out of this rapid growth and explosion of AI and infrastructure, and in the capabilities that we get as we start to design infrastructure that can handle AI. So I live in California, and pretty much every year we get public safety shutdowns of our electricity grid, largely due to wildfire conditions or to problems that we see with fires starting to spread or just red flag conditions. California is not unlike most of the US now. We saw wildfires in Canada with terrible air. We saw wildfires in Hawaii, of course. But what's going on in California that's particularly unique is over the past 2 to 3 years, CAL FIRE, which is the state organization, has built a network of over 1,000 cameras on towers, and these are pan and tilt cameras that with a 360-degree vision that both have infrared sensors and also really good image sensing. And these cameras are creating massive amounts of live data feeds. You can see a little bit of that there, showing people who are monitoring wildfires in the state of California, the CAL FIRE teams, everything that's happening around them. Now, that in itself is pretty cool, the fact that we can stream all these images and they can go look at them. But what's even more interesting is they're now starting to apply machine vision to all of these streams and highlight in real time when something looks like it's burning or something is happening. And this is then they point out to a human operator who can look at it and judge, okay, this is something I need to go and explore more, or this is something that that I'm not going to worry about. In really the 2 to 3 months since they've turned on the machine vision, the impact has been absolutely remarkable. So the benchmark is, do I detect a fire faster than 911 calls? And thus far, on 77 different instances, they have detected fires before 911 calls and sometimes more than 30 minutes ahead of 911 calls. Now, to give you some context, for a lot of the fire organizations, if they can get to a fire when it's still small and set up ways to control it, they're infinitely more likely to be able to save lives, save property, to really handle the fire in a much smarter way. Now, there's other benefits that we're going to see from this infrastructure as well, because if you can imagine putting these kinds of cameras on towers all over California, you'll also be able to start seeing lots of other interesting capabilities and lots of other data collection. But when you look at this in aggregate and you kind of dial out, this is essentially the fog that I was talking about. Initially, they don't have much compute on the towers themselves, but they probably will in the future. And so that will help these cameras be even smarter and be able to identify perhaps smaller and smaller fires or even precursors to fires. And at the same time, the systems back at UC San Diego, which is training this, they're going to get better and better at identifying fires. And just from smaller bits of what they see. And in the near future, they'll probably be able to predict with much greater confidence for human operators, hey, this is something to watch. And so this is what you can actually see when you look at this in real time. You see all of those arrows on the map. Those are all locations of the towers. So it really covers most of California. And on the right is a bunch of panels. And that image there, which you see, I actually pasted that in. That's an image of a live fire that was actually grabbed and was flagged very quickly so that the state could get out there and take care of that problem before it became something much bigger. So that's what I mean when I say incredible opportunities from what we're seeing with cloud, AI, and building out an infrastructure to accommodate AI over not just the next couple of years, but really the next 20, 30 years. Because that's going to be the new paradigm for how infrastructure operates, how IT operates, how technology operates, and ultimately how we as citizens operate in our lives. So this is another picture from Instagram. So they actually have a really interesting Instagram feed. If you want to subscribe to it, it's Alert California. It's the name of the project. And you can see there's the fire. So I wanted to thank you for spending this time with me and for really listening and sharing your most valuable resource, which is your attention. Hopefully you have some questions. We'd be happy to answer them. And hopefully Nallas, if you have Nallas folks you want to talk to with questions about cloud, AI, any of these kinds of things, go ahead and contact them after this event.
Thanks, Alex. Okay, so we have a few minutes to take questions from the audience. Let's see what we have. Just waiting for them to come in. Okay, here's one. The question is, if I am using Azure or AWS for computing / building my generative AI-based solutions, why would I care so much about Nvidia or AMD unless I want to invest in those companies?
So it's a really good question. You might not care. It really depends on your workload. Right now, Nvidia probably their GPUs are the most efficient and probably the most capable. So you might get more workload per dollar out of that, or more compute per dollar out of that. Also, Nvidia, because they control the CUDA software stack, which is used for integrating AI and hardware, that's the most efficient system out there right now. They also have expertise if you're actually going with their cloud. But to be candid, for the large majority of organizations running AI workloads, you don't necessarily need a giant sledgehammer. You probably would be totally fine with AMD or Nvidia on either cloud, any cloud you choose. That said, you probably would want some help in tuning your solution, making sure that it runs the way you want, and optimizing it, because it's very easy to burn a lot of cloud resources training AI models unless you understand what you're doing.
Thanks, Alex.
And feel
All
free to
right.
follow up on any questions about that with the team. I'm sure they have some expertise.
I think we have at least one more question. Just bear with me for a minute. I see somebody posted an article about security concerns.
Yeah, it's a great article. So researchers from the Wiz yesterday revealed that Microsoft had inadvertently exposed a whole lot of really sensitive data about both customers and their own internal systems, specifically in the foundational models. Um, and so there are real security risks around AI and in infrastructure, without a doubt. I mean, there's also another article came out today about how AI is inadvertently training on API keys. In some instances, we've seen cloud secrets go out in AI. So you have to be really careful about this. I would recommend strongly that the AI that you use, has liability coverage. So Microsoft is offering it. I think a few other folks are offering it. And at the same time, just because you use AI doesn't mean that you can take your hand off the wheel, right? It means that you probably actually need to accelerate all of your other processes around security, around code review and audit, because as you get more efficient, you're really going to have to learn to do that more quickly, but also with the same intensity. So it's a real challenge. A lot of folks that I hear about as well are automating software scanning, SCA, SAST, or making sure that they also have additional infrastructure scanning capabilities around configuration management, secrets protection, etc. Over time, this should start to get better as we see more things around code signing and SBOMs, and we see a better chain of provenance around software and configurations. But right now, the CI/CD pipeline and code itself, there's a lot of risk with the AI tools, and so you do have to make sure you're on top of it. So I see a question about GPU shortage.
Yeah,
Why?
that's next.
Very good question. Essentially, they can't make enough GPUs to meet demand right now. Sounds crazy because I mean we're used to there always being enough capacity. This really goes down to the fact that there are very few factories like TSMC or semiconductor fabs, they call them, that can handle the very best or the very sort of most modern types of processors, which are 3 nanometer, something like that. And so because there's limited production lines and they're struggling to bring them up in time, there are not enough GPUs to go around. Part of the problem around that too is that the very large companies are buying as many GPUs as possible, and Nvidia is also buying them themselves for their own cloud. Google is actually building their own TPUs, specifically in factories and fabs, and they're buying massive amounts too. So all of that, they're doing that at Broadcom. So this all plays into the fact that there's actually just a lot more demand than there is supply right now. They think it will clear in a couple of years, though it's hard to tell. Sorry, let's see. What was the next question? I think it flashed and then I lost it.
Sure.
Apologies.
Yeah. If all the small to medium companies start using AI models, are they cloud providers, MS, AWS, or Google prepared to are the cloud providers, MS, AWS, or Google prepared to support the community? Do you have any insights?
I would say generally yes, because all of them have services now that will give you AI capabilities or run AI models for you. So I think Google, GCP, Azure, AWS, all of them will support a decent variety of AI models. And they do have teams that can help you integrate. I mean, in fact, they're very incentivized to do that because they see that as being a big driver of their business going forward. Now, that being said, if you wanted to try to build expertise in house, you might want to you might want to try a few folks, uh, maybe working with some of the smaller large language models, like smaller versions of Llama, and really trying to create something bespoke yourself that you could even run on your own cloud instance without necessarily having to worry about getting it up and running as a service or paying for a managed service in the cloud.
Great. Thank you. Okay, one last question, unless more come in, which we do welcome. How can municipalities or local governments be more friendly to AI investment?
It's a great question. So I think to a certain degree, that's more a question of how can municipalities and local governments be more friendly to tech investment in general.
Yeah.
And so I think there's a couple things around that. Um, at least for AI, let's separate that into infrastructure versus products. For infrastructure, fast permitting, working collaboratively with the companies that need to build data centers or need to build compute facilities, understanding that maybe though that some of what they'll be betting on in the future is not necessarily clear. Also, working really closely with these folks on conservation and consumption issues. So a lot of the cities do worry quite a bit that the large infrastructure projects are going to come in and suck up the power grid or suck up all the water. But I think when you see communities work very collaboratively with them, then they tend to get a lot of investment. Um, on the capability side, I mean, that's much more a question of like, how do you get educated workers? Because they can live anywhere. You could say simple things like, oh, tax benefits, but I don't actually tend to believe that works. Much more to the point, I think, would be making sure that your educational system is supporting the latest in these types of capabilities. Because, yes, a lot of things are great and online now, but we also have lots of uh, opportunities around studying at universities with researchers. People that I know, their kids are now studying AI and large language models at state schools that are not necessarily Harvard or Stanford. And in those areas, they're seeing demand for those kids. Was there one more question? I thought I saw one more there.
I don't think so. I think we may have gotten to the end of the questions.
Okay.
Unless anybody wants to feverishly type one more in, that may be the end of the list. Alex, I can't thank you enough for this very relevant and exciting topic. Really appreciate the conversation. I will mention to the audience, we do have time for a VIP chat. We are sharing a Teams link in the LinkedIn comments for anybody who's interested in interfacing with the Nallas leadership team to talk further about AI, the services that Nallas has to offer. We invite you to meet us here. We'll be there, just waiting for your questions, inquiries, or just to have a simple dialogue around your reflections on this talk.
Thank you, everybody. I really enjoyed talking to you. And the questions are great. Keep them coming.
Thanks so much. All right. See you on Teams, everybody.